Welcome back, folks. As we finish out this course review number 5 and specifically looking at doing our trial solutions for the method of undetermined coefficients. So if you haven't already, please stop the video and answer part A here, where I want you to show that the homogeneous solution, the corresponding homogeneous ODE, this one right here, has a family of solutions that looks like this. So I'll review that in a solution for you, but I want you to try that. So if you haven't done that, stop the video and give it a shot. So now what I'd like you to do is we want to give the trial solution for this non-homogeneous ODE here. And the key thing that I want to point out is notice what I had you do first. I had you look at the homogeneous ODE. You cannot answer this question until you look at the homogeneous family of solutions that I had you answer in part A. Because I don't want to copy it each time, I'll just remind you each time to look at YH in part A. And now we're ready to give a guess for this trial solution. And remember that our guess needs to include not only generic forms of the functions that we see in the homogeneous forcing function, but it needs to take into account all possible derivatives that could show up. Not just 5 orders derivatives, by the way, all possible derivatives that could ever show up as we differentiate this. And so as I take the derivative of this product of e to the minus 3t and the sine of 2t, as I take the derivative of those products, I'll get factors that look like maybe minus 3 e to the minus 3t, or 9 e to the minus 3t, or negative 27 e to the minus 3t. All of that can be summed up by ae to the minus 3t times, because there's always a product here, sine of 2t. But what else could happen? As I'm taking derivatives here, if I'm doing my product rule, I do the derivative of the first times the second. Sure, that's what I've captured here, but I could also do the leaving the first factor alone, taking the derivative of the second, following the formula for the product rule. And so what shows up when I take the derivative of the second factor? Well, in this case it would be the 2 cosine 2t, or if I take the derivative again, I get a minus 4 sine 2t, and then taking the derivative again, cosines and sines, and it starts to alternate. So the other thing that could show up is an expression that looks like be to the minus 3t times the cosine of 2t. And then here, as I think about taking derivatives of this product, we could have quadratic terms, linear terms, and constant terms show up in my product rules, but all of them would be multiplied by e to the t's. So there's my guess here for y sub p, and I should have written y sub p equals. Okay. Now, before I move on, in this case I'm correct, but I should always check. Notice that none of these expressions showed up in our homogeneous family of solutions. By the way, folks, I have to fix an error here. I can't reuse the letter a here, nor b. So we have ct squared plus dt plus capital E. I can't reuse the letters that I'd already previously used for those as yet to be undetermined coefficients. So now let's give the trial solution for this one, and this is where this gets a little bit dicier. Normally, what would we guess for our trial solution? Well, we guess for y sub p that it just has to look like some sort of constant, because that's the structure of the function that shows up. If I take successive derivatives of that constant, I just get down to 0, and it remains at 0. So no other terms could ever show up for my particular solution. But this is where I'm saying we need to look at the homogeneous family of solutions. Because if I go up and I look at the homogeneous family of solutions here, you'll notice that I have a constant solution in my homogeneous family of solutions. And sure enough, if you're just plugging the number 3 into this and plug it into this ODE, you get a true statement set equal to 0. So it's certainly not going to equal 1. So the first thing we're going to try to do is, the first thing to try to do is to try to multiply it by a factor of t. So now I've got a constant times t. But again, it's true that if I were to take enough derivatives of at and plug it into this expression, I'd still have the true statement 0 equals 0, and that means that at belongs to the homogeneous family of solutions, so t won't cut it. I might try t squared. Don't write this down. I might try t squared, but again, the same issue. And so it's not until I multiply this by at cubed do I get something that when I take enough derivatives and collect terms and whatnot, it's possible that a constant factor might survive after cleaning all that up. And so that's my guess then at the particular solution. Okay. So again, we have something similar here. Normally, what would we guess for a linear function? Normally for a linear function, we would guess at plus b for our guess. But here, again, we want to make sure that we look at the homogeneous family solutions. But here, what will we pick? Well, I already have an at in my homogeneous family solutions, and I already have a constant b. Okay? Now this part's a little bit strange. What we do is we take what would normally be our guess. Let me write y sub p there. We take what would normally be our guess, at plus b, and we multiply it by enough factors of t to clear the homogeneous solution. Notice that if I multiply by a factor of t, neither of those two terms clear the homogeneous family of solutions. But even if I tried t squared, now while it is true that the at times t squared, that would give me at cubed, that would clear the homogeneous family solutions. My normal trial guess in its entirety would not, because I would still have a bt squared, and that shows up in my homogeneous family of solutions. So what do I need to multiply this by? The answer is t cubed. And that's our answer to this problem. Okay. Continuing on, let's look at this example here. Normally, our guess at y sub p would be at squared plus b for this first term that shows up, plus ce to the 5t. Normally that would be our guess for just any old generic nth order homogeneous ODE, but you always have to look at the homogeneous family of solutions. And notice, just as we've had in each of these cases, some of those expressions show up in the homogeneous family. Okay. Now in this case, I need to clear all of these. I have a mistake here, folks. This should say at squared plus bt plus c. Let me fix that real quick. So here I'm going to have to multiply everything by a factor of t cubed to make sure everything clears. So we'd have at squared plus bt plus c, and if I multiply it by a factor of t cubed, now all of the terms in this guess that correspond to the function t squared, now all of those terms clear the homogeneous family of solutions. And then what are we going to do to d e to the 5t? Well, you might think it might be enough to multiply it by a factor of t, but notice that because this was also related to a repeated root, and you should have seen that when you did part A, it's related to a repeated root. We've already got a factor of t. This would still not clear it, and in this case we'd multiply this one by a factor of t squared. Now I get dt squared e to the 5t, and so the trial solution for that particular that term clears everything in the homogeneous family, and we've accomplished our goal. So folks, the last thing I want you to do is I want you to try all of this one more time on your own, and this is a former test question that I want you to give it a shot with and see how that works out. You have the solutions to that, but please folks, if you find that you're still not getting this, you'll want to come see me, and sooner would be better than later. Thank you folks. I hope this clarified some of the confusion with the method of undetermined coefficients, and I'll see you next time.